Hey everyone, TomBoss21 here. Today we're diving into the most crucial metric in poker, expected value or EV. If you want to maximize your profits at the tables, what you're actually doing is trying to maximize your expected value. But what exactly is EV? What does it measure and how do you calculate it? Let's break it down. Let's get to the heart of the question. Expected value in poker measures the long-term value of a strategy, accounting for all possible outcomes. Your goal is to aim for plus EV decisions. Maximizing your expected value means maximizing your long-term profit. Remember what I said, long-term and all possible outcomes. We're not talking about coolers or one-offs. We're talking about all the possible things that could happen, right? The long-term value. Expected value is just a weighted average. It is the sum of outcomes times the probability of those outcomes. So if you know the value of every possible outcome, and you know how likely each of those outcomes is to occur, then you can calculate your long-term value. That is EV. Let's start with a super basic example. You roll a 6-sided dice, and you want to calculate the expected value of your roll. You have a 1 out of 6 chance of rolling any number on a dice, and you can get a 1 through a 6. So just multiply each number by 1/6, add them together, and you end up with 3.5. Pretty easy in this case. All right, let's make it a little more interesting. Let's play a game. You pay me $10 every time you roll a 1 through a 5, but I'll pay you $100 every time you roll a 6. So you're gonna lose a lot, but when you do win, you're gonna win big. Should you play this game? Let's calculate the expected value. So 5/6 of the time, you're gonna pay me $10. That works out to $8.33. And 1/6 of the time, I'm going to pay you $100. That works out to $16.66. Add those together, and we find your expected value is $8.33 per roll. So even though you're going to lose 5 out of 6 times, this is a great game in your favor. All right, let's try a poker example now. You shove $80 into a $100 pot with the stone cold nuts, and you think your opponent will call half the time. What's your EV? Well, there's only 2 outcomes. Either they fold or call. If they fold, you win the $100 pot, and if they call, you also win their $80 call. So the value is 100 if they fold and 180 if they call. We multiply each of these by 50%, given we think they will fold and call half the time. Therefore, your total expected value is $140. Easy enough, right? Let's look at this from the other side. So now you're the player facing the shove, holding a bluff catcher, and you think they're bluffing 25% of the time. What's the expected value of calling? Well, if you call and lose, you lose your $80 call. And if you win their $80 bet and the $100 pot. The probability of winning is just 25% since we assume that's how often they're bluffing. And that means they're value betting 75% of the time. Again, we just multiply these out, add them together, and we can find that the expected value of calling is negative $15. So this is a bad call if they're only bluffing 25% of the time. You need them to be bluffing more often to make this call profitable. How often exactly? Well, calculate your pot odds to find out. All right, let's step it up a notch. You're playing a 100 big blind cash game, cutoff opens, you 3-bet on the button, they 4-bet, and you are considering a shove with ace-king offsuit. Let's make some assumptions. You think that they're going to fold half the time, and when they do call, they'll call with a range that looks something like 10s plus ace-king pure. Your ace-king has 40% equity against this range. What is the expected value of shoving? Now down below you can see the exact stack sizes as well as the raise sizes. Let's break this down step by step. There's only 3 outcomes. Either they fold, they call and we win, they call and we lose. If they fold, we get 33 big blinds. How did I calculate that? Well, it's just the amount we 3-bet with, 8.5. Remember, this is a sunk cost. If we fold, we lose that. The amount that cutoff 4-bet us with, that's another 23, and the 1.5 from the folded blinds. So 8.5 plus 23 plus 1.5 works out to 33 big blinds. That's our value if they fold. If they call and we win, we get that 33 big blinds plus another 77 big blinds. You can see on the top right corner here that cutoff has 77 big blinds remaining. And so 77 plus 33 is 110 big blinds. And if they call and we lose, then we lose our effective stack. losing 91.5. Okay, so we know the values. Next, let's calculate the probabilities. We assume that they fold half the time, so that's 50%. We assume that they call half the time, and that when they do call, we're going to win 40%. That's our equity with ace-king against their range of 10s plus ace-king. So 50% times 40% is 20%. And finally, we calculate the probability of calling and losing. So that is 50% times 60%. So there's a 60% chance that we lose when we call with ace-king. Now that we have the probabilities and the values, it's pretty straightforward to calculate the expected value of shoving. Just multiply them out and add them together, and we find the EV is 11.05 big blinds. So yeah, this is a pretty profitable shove. When I look at this, it's super counterintuitive that winning is worth 110 and losing is worth negative 91.5. Like, these value numbers don't make a ton of sense in my head, right? And the thing is, this is just what happens when you set fold equals 0. A more intuitive method you can use instead is to track your expected value relative to the change in your stack. That is to say, like, how much will my stack change compared to when this hand started? So if they fold, I'm going to win their 4-bet and the blinds, which is 24.5 big blinds. If I win the shove, I'm going to win their stack and the blinds, 101.5 big blinds. And if I lose the shove, I lose my stack, minus 100, right? Like, these numbers feel super intuitive to me. And then at the end of this, all you do is just add on however much you've contributed to the pot so far. So I've contributed 8.5 big blinds, and so I can just multiply these together, add 8.5, and I get the same value. So 11.05 is the exact same EV we calculated earlier with these simplified numbers, just using a more intuitive method. Now, if this is confusing, another way you can think about this is by thinking of it as the expected change to your stack versus folding. Here, let's define folding as negative 8.5 big blinds, right? And shoving, we're going to calculate the exact same way. And if you do the EV equation, you find that shoving is worth 2.55, and folding is worth negative 8.5. Because remember, this is what we 3-bet. This is how much we lose if we fold. And therefore, shoving is 11.05 big blinds better than folding, right? So regardless of how you look at it, regardless of whether or not you use fold equals 0 or expected change to stack, you're always going to find that shoving is this much better than folding. For this next example, I want you to imagine that you're negotiating a deal at the final table of an MTT. There's 4 players left, including you, and you can see exactly what the chip stacks and the proposed deal are. Now, you're one of the shorter stacks here, and what they're offering is essentially called a chip chop, right? You have 1/5 of the chips, and therefore you should win 1/5 of the prizes. All right. Now, I want you to take a moment and consider if you think this is a good deal, a bad deal, or a fair deal. This is not a fair deal. You shouldn't take this. The value of your stack is not $200, it's closer to $236. And the reason is that a chip chop doesn't accurately predict the value of your stack. What tournament players use is something called the independent chip model, or ICM for short. And what ICM does is it predicts how likely each player is to place first, second, third, fourth, and so on. Once we have these placement probabilities, we can multiply them by the size of the prize. So again, we're just breaking down, here's all the outcomes, here's the probability of those outcomes, and the value of those outcomes. Multiply them together, add it all up, and you find your true tournament equity is closer to $235.70. For this next example, I'll show you how we can use EV to calculate the implied odds of drawing. Imagine you're drawing to the nut flush on the turn. Villain bets 12 into a pot of 10. Let M equal the extra money we win on the river when we hit our draw. Now, 20% of the time we hit our draw, and we're going to win 22 plus M. So we'll win the 10 pots, the $12 bet, as well as any extra money M that they put in. 80% of the time we miss, and we lose our $12 call. How much extra money do we need to win on the river in order to break even on this call? Let's calculate this out. Now, for simplicity, we're assuming that we always win when we hit, and we always lose when we miss. The expected value of calling is just how often we win times the amount we win, which in this case is 22 plus M, plus how often we lose times the amount we lose, which in this case is minus $12. Now, if you rearrange these terms to solve for M, setting EV equal to 0 to find the break-even point, you'll find that M equals 24 big blinds, meaning we need to win at least another 24 big blinds on the river when we hit in order to break even on this call. Now, if we think about this, the pot is going to be 10 plus 12 plus 12, so 34. So we need to win about another 2/3 of the pot when we hit our draw in order for this to work. If villain is going to shut down on a lot of draw completing rivers, then this probably isn't any good. But if they're pretty aggressive, then this is probably a decent call. Now, knowing this, we can use this type of equation to figure out a more general formula that we can use to plug in stuff in other situations. So this is just a general formula for drawing, where M is the required extra winnings on the river, so how much money you want your opponent to put in on the river when you hit your draw. Lose percentage is just how often you'll miss. Win percentage is how often you'll hit. Lose dollar amount is the amount to call, current bet, and then win dollar amount is the pot plus the bet. That is to say that the size of the pot plus the size of the current bet. So you take all of these, you plug them in, and you can figure out exactly how often or exactly how much money you'll need them to put in on the river in order for your draw to be good. Lastly, I'll teach you a powerful technique called decomposition, and this allows you to break down a formula into its component parts. EV is a formula, it has parts, we can separate those out. Now, why exactly would you want to do this? Well, let me ask you a question. Here I've returned to this GTO simulation, and we can see the expected value of opening different hands from the cutoff. Now, this is a pretty wide open. Keep in mind, this is chip EV, but take a look at a hand like 7-5 suited. This hand has an expected value of 0 big blinds. It's break even. But what if I wanted to know how much EV does this hand get from stealing the blinds, from getting called, and when I face a 3-bet? Like, what about ace-8 offsuit? How much of your EV of this break-even hand is derived from stealing the blinds, getting called, or facing a 3-bet? We can calculate the same thing for any hand in range. And the reason this is useful is because if you have an idea of the table dynamic, you can adjust your range based on the incentives of your hand. But you can't really do this without first figuring out how your hand makes money. So decomposition, in short, allows you to figure out the incentives of your hand. Let's walk through an example using 7-5 suited. So we already know the overall expected value of this hand is just 0. It's break even, right? But that 0 doesn't mean it never makes money. Sometimes it makes a ton of money. Sometimes it makes a bit of money. Sometimes it loses money. And I want to get a feel for how this hand actually derives value. And this may look complicated, like how do you even figure this stuff out? But let's just plug in what we know and go from here. So what is the value of stealing the blinds? Well, it's just 1.5 big blinds. And what is the value if we get raised? Well, I'm never calling 7-5 suited facing a 3-bet, so it's minus 2.5 big blinds. Now, I'm not saying you can literally never call, but in this example, I'm never calling. So we have these values, right? Now, we don't know the actual value if we get called just yet, but stay with me. What we can do next is calculate the probability, all right? So we need to know the probability of at least 2 of these 3 things. And this is where it gets a little tricky. Before I go on, I need to explain how to combine probabilities of multiple events. So first, you need to think about whether these are ands or ors. So and meaning all events must occur, and or meaning any of the events can occur. So for example, if I want to calculate how often cutoff steals the blinds, all I need to do is just multiply how often button folds, small blind folds, big blind folds facing my raise. If you go through the GTO Wizard solution, you can see it comes out to 79%, 83, and 58. And therefore, multiplying those together, I can know that cutoff will steal the blinds 38% of the time. Now keep in mind that the actual steal frequency depends a lot on your opening size in GTO. Maybe I'll cover that later, but that's a pretty easy calculation. Next, I want to figure out how often I'll face a 3-bet. And this one's a little trickier because these aren't and statements, these are or statements. So either the button raises or the button folds and then the small blind raises, or both of those guys fold and then the big blind raises. So if any of these things happen, I'm facing a 3-bet. Now I'm going to ignore squeezes and stuff for simplicity, but We can calculate this out by, and the easiest way to do it is to just convert ors to ands. There's different techniques, but this is the most straightforward. So how often will I face a 3-bet? Well, that's equal to 1 minus how often I will not face a 3-bet. And it's easier to calculate that. So 1 minus no button raise and no small blind raise and no big blind raise is equal to the probability of facing a 3-bet. So 1 minus the button raise percent, 1 minus blah, 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 blah. Anyway, we can plug in these numbers and calculate out that we will face a 3-bet 24.5% of the time, excluding squeezes and like weird spots, right? Now we know the probability of stealing the blinds as well as how often we'll face a 3-bet. Let's go ahead and plug those back into our table. Okay, so here we already can figure out some more values. We know the value and the probability of stealing the blinds. It's just 1.5 times 38%, so we know the expected value of this one as well as the getting raised one. Multiply those out, and now what we can do, since we have 2 out of 3 of these, and we know that they sum to 0, we can just say, okay, well, 0 equals this plus this, which is 0.042. And the probabilities, well, they've got to add up to 100%. So we know how often we'll get called, and that means we know the value of our hand when it's called, right? We know EV is just probability times value, and therefore value is EV over probability. And so we can figure out this entire table just by starting with 4 data points. And now keep in mind, this isn't quite perfect because the get called term technically includes the time someone calls and then someone else squeezes. So, but whatever, it doesn't have to be perfect. The reason I wanted to do this was to see, okay, as it turns out, my hand doesn't derive a whole lot of value when it gets called. Like the payoff when I get called is not great. But it's not negative either, right? And the thing is, once you've got this, it's pretty easy to just build like a spreadsheet and calculate this for a bunch of different hands. All right, that wasn't too bad, but here's the thing. We haven't accounted for blockers at all. So the thing is, a hand like 7-5, it doesn't actually steal the blinds as often, and you probably face a raise more often because 7-5 has garbage blockers, right? You're blocking a bunch of hands that fold. You're not blocking all the hands that raise you, and that's a bit of a problem. So when we recalculate this with our blockers in mind, we end up with these new probabilities, and therefore more of our hand's value is being derived from when we get called. Now, if that said, 7-5 suited, still not making a lot of money from getting called. Like, we'd way rather steal the blinds than get called. But as you can see here, when you break it down this way, not only do you get a sense for, hey, here's how often I need to steal, here's how often I need to call, my hand makes more or less money when it gets called, etc. Like, you can see exactly how your hand is generating value. So let's try a quiz next. Cutoff opens 2.5x, and we're using the same concept as before, just the chip EV solution. Which of these do you think is the most valuable hand when you get called? Ace-5 suited, Ace-10 suited, or 7-10 suited? Take a moment to consider your answer. Well, it turns out to be Ace-10 suited with a value of 1 big blind when called. Now, I think a lot of you guys might have guessed Ace-Jack offsuit, but those offsuit high ace hands actually don't have a great value when called. People underestimate the expected value or the implied odds of suited hands. So we can see here Ace-5 doing surprisingly well, and 7-5 suited again doesn't actually make a whole lot of money when it gets called. All right, let's try another one. Which of these do you think is the most valuable hand when you get called? Ace-King offsuit, Ace-Jack suited, 6-6, or Queen-9 suited? Well, no surprise here. It is Ace-King offsuit. And Ace-King, I mean, it doesn't actually derive a lot of its value from calling. Like, most of the value from Ace-King comes from the fact that you can re-raise, the fact that you have excellent blockers. But even then, it's still a premium hand, and it should not be underestimated. I think a lot of people would have chosen 6-6 here just because it's so easy to set mine with a hand like this. Like, I feel like 6s is just easier to play. But No, ace king offsuit in this case. All right, last example. Now, before we were looking at 6 max here, I want to think about a 9 max spot, and this is NL50. So under the gun opens 2.5x. What is the most valuable hand when you get called? Now keep in mind, there's a lot more people in front of you this time. 9s, king 5 suited, ace jack off, or 6-5 suited. Well, it turns out to be 6-5 suited in this case. And you can see that our EV when called has gone way down, right? And this is because we're opening a tighter range. We expect to get called by tighter ranges. So even 9's not super valuable. Ace jack off actually losing money in a lot of cases. Now, something to keep in mind here is that the way I'm calculating EV when called accounts for all the possible calls that could happen, right? At least that are available within the solution. Like some of the middle positions might be 3-bet folding, but you get the idea, right? Like our hand is not making a ton of money when called. And so when you're under the gun, you should really think about if you're at a table that's going to 3-bet a lot or call a lot. Let's summarize what we've learned today. The first rule is to always be maximizing EV. The goal of every move you make in poker is to maximize your expected value. EV is defined as the weighted average of all possible outcomes, so just sum up the payoffs of every outcome times the probability of every outcome. EV is most useful for off-table calculations of final actions, so shoves, river calls, and the reason is just that it's simpler to calculate if that's the final action. When there's future action ahead, you can use concepts like the implied odds formula or decomposition to understand the incentives of your hand and the incentives of your strategy. Anyway, that's all I've got for you guys. If you need something clarified, feel free to ask questions in our Discord server or leave a comment. And don't forget to check out the description for some useful further resources. I've linked a couple blogs in there you can check out. Thank you all for watching. I hope you got something out of it. And as always, happy grinding.